AI chatbots, I mean, they feel like pure magic, right? But they're not. They are incredible feats of engineering. And today, we're going to pull back the curtain and break down exactly how a large language model is built step by step.
So what's really going on inside these things? It's so easy to picture some impossibly complex, almost alien machine. But what if I told you that at its core, it's actually surprisingly simple?
Okay, check this out. Let's take a really powerful model, like Meta's Llama 2. If you break it all down, it's basically just two things. First, you've got this massive 140 gigabyte file that is just jam-packed with billions and billions of numbers. We call them parameters or weights. And the second thing, it's a tiny little program, only about 500 lines of code, whose only job is to read that giant file. That's it. That is the chatbot. A giant list of numbers and a tiny instruction manual.
So how in the world does a file full of numbers and a little bit of code manage to write poetry or explain quantum physics? Well, it all boils down to one single fundamental skill.
You know, despite all the mind-bendingly complex stuff they can do, deep down, every single large language model is just playing one simple game over and over and over again. And that's the whole secret. The entire game is just, what's the most likely next word in his sentence? Every clever answer, every creative story you see, it's all built one word at a time, just by making the most probable guess. And, you know, this is super important because it explains why these chatbots sometimes hallucinate and just make stuff up. They aren't thinking. They're just masters of statistics, predicting the word that feels right, even if it's totally wrong. Let's make this super real. If I say to you, in that match, Virat Kohli hit a... Your brain just instantly lights up with possibilities, right? Century, 6, 4. You're automatically weighing probabilities based on everything you know. Well, the AI is doing the exact same thing, just with a lot more math.
So here's a peek under the hood. The words you type in, like cat sat on a, they get fed into the neural network. The network then uses those billions of numbers we talked about to calculate the probability of literally every possible word that could come next. And in this case, it lands on Matt with a 97% confidence. It spits out that word, adds it to the sentence, and then it does the whole thing all over again to figure out the next word.
Okay, so how does a model get so good at making these predictions? Where does it get all this knowledge? Well, it happens in a few stages, and that first stage is by far the biggest. A good way to think of it is like compressing the entire internet.
So the journey from a totally blank slate to a helpful assistant, it basically happens in three main phases. First, there's pre-training. That's where it learns about the world. Second is instruction fine-tuning. That's where it learns to have a conversation. And third is preference fine-tuning, where it really learns how to be helpful and safe.
And this slide right here really shows you the before and after. It's fantastic. On the left, you have a model that's only been pre-trained. You ask it, what is an LLM, and it just spits out total gibberish. It's like a brilliant, but very confused librarian. It knows all the patterns, but it has no idea how to actually answer a question. But then, after the other training stages, you get that clear, helpful response on the right.
So that pre-training phase is all about absorption. The model just inhales a colossal amount of text from the internet, and its only job is to learn the patterns, grammar, facts, different styles of reasoning, how ideas connect. It basically becomes what some researchers call an internet document simulator. It knows what text from the internet is supposed to look like, but it doesn't know how to chat. And the scale of this, it's almost impossible to wrap your head around. A model like Red Pajama was trained on 1.2 trillion tokens. A token is basically a word, or sometimes just a piece of a word. That number is just astronomical.
So where does all this data come from? Well, it's a mix of pretty much everything. The huge majority comes from these massive web archives like Common Crawl, but it also includes billions and billions of tokens from books, from all of Wikipedia, scientific papers, and even computer code from places like GitHub. This is how it builds such a wide-ranging understanding of the world.
Okay, so now we have this incredibly knowledgeable but kind of useless base model. We have to turn it into something we can actually talk to. This is where we apply the polish that turns it from a simple text predictor into a real assistant.
Honestly, a great way to think about it is this. The pre-trained model has read every single book in the library, but it has zero social skills. It doesn't know how to answer your questions or follow instructions. So these next steps, they're all about teaching it good manners.
This brings us to stage 2, instruction fine-tuning. For this part,
Humans create a much smaller but very high-quality data set of questions and perfect answers. The model gets trained on these examples, and by seeing them, it starts to learn the format of a conversation. It learns to see a question and then provide a helpful, relevant answer.
And the final layer of polish is stage 3. This is often called RLHF, which stands for Reinforcement Learning from Human Feedback. Here's how it works. The model generates a few different answers to a prompt. A real person then looks at them and ranks them from best to worst. This feedback then gets used to reward the model for making answers that we humans actually prefer. It's how it learns to be more helpful, less harmful, and just better aligned with what we want.
And this flowchart just ties it all together beautifully. You start on the left with these massive heaps of internet data to create the base pre-trained model. Then, in the middle, you use that high-quality Q&A data to teach it how to follow instructions. And finally, on the right, you use direct human feedback to really optimize it to give responses that people actually like.
And this just highlights the massive contrast between these stages. Pre-training is the heavyweight champion. It's incredibly demanding on computers, costs millions of dollars, and uses those giant, messy datasets. Fine-tuning, on the other hand, is like the skilled artist. It's way cheaper computationally, and it uses much smaller, carefully crafted datasets.
So when you put this all together, you see this incredible journey, a process that takes what's really just a digital blank slate and sculpts it into the powerful AI assistants that we're all starting to use every day.
So let's do a super quick recap. Every LLM starts as a blank slate. It learns about language and facts through that massive pre-training phase. It becomes helpful and conversational through fine-tuning. And at the end of the day, all of this amazing capability is just encoded in that giant file of numbers and a simple bit of code.
This entire process is just fueled by two things: data and computing power. And as we build bigger and bigger models, it brings up a really critical question. What's the limit? Can we just keep doing this forever?
Well, one very real bottleneck might be the data itself. Some researchers are actually warning that we're burning through high-quality text data so fast that we might literally run out of new stuff from the internet to train these models on, maybe within the next few years. It's a fascinating problem and a powerful thought to end on. Thanks for tuning in.